right, now we're going to go through solving one-step equations. This is chapter 2, section 1. And solving one-step equations, what we're going to do, or what we're trying to do, is we're trying to take what we learned from last chapter in terms of setting up the equation, and now we're going to focus mathematically, how do we solve it? So how do I go through and solve this problem? So if we take a look here, solving one-step equations. This first situation, this diagram right here represents the amount of money that each player earns. So the two of them are playing a game, and we hand out money to player one, we hand out money to player two. But what we did is the money is inside this treasure box, and we're trying to figure out how much money is inside of that treasure box. Well, if I want to figure out what is inside of this treasure box, I'm probably going to start taking away money from each player to see what's left over. So if I took this $1 away from player two, then I'd probably have to take away $1 from player one. If I take away $2 from player two, I would have to take away $2 from player one. If I take away $1 from player two, I need to take away $1 from player one. And then $2 from player two, $2 from player one, $5 from player two, $5 from player one. So now we can look at this and we can say, all right, well, player one has 10, 15, 16, 17, 18, 19. Player one has $19 left over. So if player one has $19 left over, that means inside of this treasure box, there must be $19. Because that's the only way that the two sides are going to have the exact same amount of money. Now, the big takeaway from this startup problem here is that if I crossed out $1 on the right-hand side, I had to cross out $1 on the left-hand side. It's not like I could take away $1 from player one and then take away $5 from player two. That wouldn't be fair. So as we go through and solve equations, what I want you to understand is if I take away something from one side, in order to keep it fair, I have to take away the exact same thing from the other side. So if I took away $5 from the right, I have to take away $5 from the left. That's the only way that I'm going to keep this thing fair. All right, so our objective for this lesson is to solve one-step equations in one variable. So whenever we have one variable, we're going to learn how to solve these types of equations. Solving these equations follows the addition and subtraction property of equality. So we'll talk about those here in a second. Here's a list of all the vocab. And in the solving piece, what we just did on the previous slide, you may have used reasoning to find the amount of money in the chest. In this lesson, you will learn to solve problems like that one that we just did by using equations. So the essential understanding, the essential piece, equivalent equations. The essential piece is player one had this much money, and it was the exact same amount as player two. They were equivalent amounts of money. So equivalent equations. What we're going to do is we're going to have some type of expression over here, and we're going to have an expression over here, or maybe a number, and they are going to be equivalent. They're going to equal each other. So equivalent equations are equations that have the same solution. So this player one has the same amount of money as player two. You can find the solution of a one-step equation using the properties of equality. So here's your addition and subtraction property of equality. The addition and subtraction property of equality, all it says is if I take away $5 from player one, I have to take away $5 from player two. That's your subtraction property of equality. Whatever you subtract from the left side, you have to subtract it from the right side. Your addition property of equality, if I was to give player one money, let's say I gave player one $2, then the only way that I'm going to keep this fair, the only way that I'm going to keep this equal is if I give player two $2. So your addition property of equality says anything you add to the left, you also have to add to the right. All right? So to solve an equation, if I want to go through the mathematical steps, the algebraic steps to solve an equation, what you want to focus on is you want to focus on isolating the variable. And what that means is getting the treasure box. Remember on the first slide how I got the treasure box all alone to figure out how much was in it? That's what you want to do. You want to focus on getting the treasure box alone, the variable. Get the variable by itself. You can isolate a variable by using properties of equality and inverse operations. An inverse operation undoes another operation. So for example, this plus 13. So in other words, player 1 has $13, player 2 has $27. Inverse operations. Since this is a positive 13, I would take away $13 from player 1. But then our properties of equality say I also have to take away $13 from player 2. All right, since this was a positive, this was a negative. That's what they mean by inverse operations. All right, so if I gave player 1 money, I would give player 2 the exact same amount of money. If I take away money from player 1, I would take away the exact same amount of money from player 2. All right, and that's how you solve these problems. So I took away the $13 and all I have left is the treasure box. The variable is your treasure box that you're trying to get by itself. So I take away from player 2 and I find out how much money is in the treasure box. I have $14 in that treasure box. And now I have my answer, and of course we can always check them. Take the 14 and plug it back into the original problem. So that's what they did right here. They checked their solution by taking the 14 and plugging it in for the x. 14 plus 13, that makes a true statement, which we talked about last chapter. We want to make true statements. All right, so what is the solution of y plus 2 equals negative 6? So if we focus on inverse operations, I'm going to take away, I want to get the treasure box by itself. So I'm going to take away $2 from player 1. I'm going to take away $2 from player 2. So the treasure box is our y. And then player 2 is in the hole, 6, 7, 8. Negative $8. So y is equal to negative 8. If I take the negative 8 and plug it in to the treasure box, negative 8 plus 2, it sure does. It equals negative 6. So that is a true statement. So we're good. All right. And another one here. So here this is b minus 3. Now this one's kind of a harder concept to grasp because I'm not really taking money away here. But I want to focus more on the inverse operations. Since this is a minus 3, the only way I can get the treasure box by itself, since this is a minus 3, I would have to add 3. And if I do it to one side, I have to do it to the other to be fair. So the minus 3 and the positive 3 equals 0. So I have the treasure box by itself, and negative 7 and a positive 3 gives me negative 4. So I find out there is negative 4. B is equal to negative 4. All right, so down here I'll work through these real quick just so you can see a couple more examples. I would add 8 to both sides, which gets me the m by itself, and this would equal negative 6. Okay, fractions, no different. I would add 3 over 2 to both sides because you're just focusing on inverse operations now. So negative 3 over 2, positive 3 over 2, those cancel out and I'm left with y equal to half plus 3 over 2 equals 4 over 2, which is 2. All right, so that was addition, subtraction. Now, you can do virtually the same thing with multiplication, division. So your properties of equality also apply to multiplication and division. So multiplication, what that says is if I multiply one side by something, I have to multiply the other side by something. So if I doubled player one's money, I have to double player two's money. Now, why would I multiply? The reason you multiply is because it is the inverse operation of division. So remember, I told you how we're trying to get the treasure box by itself. So in this problem, x over 3, x divided by 3 equals 2. The only way I can get the treasure box by itself to figure out what's in it, how much is in it, is to get rid of this dividing by 3. The only way I can get rid of the dividing by 3 is to multiply both sides by 3. Multiplication is the inverse, division is the inverse of multiplication. So I would multiply both sides by 3. The 3's divide out, and I'm left with an x. So I got the treasure box by itself, and I find out that it is equal to 6. All right, so x divided by 3 times 3. What happens there is the 3's cancel each other out. 3 divided by 3, when I put those two things together, they equal 1. 3 divided by 3 is 1. That's why I got the x by itself there. Okay? And then why would I use the division property of equality? Well, in this one, I have 5 times x equal to 20. The opposite of multiplying by 5 is to divide by 5. 5 divided by 5, those cancel each other out. They equal 1. So I would have x equal to 4. Now we can take those, plug them back in to double check our answers. If I take that and plug it in, 5 times 4 gives me 20. Up here, if I take the 6, 6 divided by 3 gives me 2. So it works out. Okay, and then problem number 3, solving an equation using division. So 4x equals 6.4. If I want to get that x by itself, I would have to divide both sides by 4. That's the only way I can get those 4's to cancel out and get the x by itself. So 6.4 divided by 4 is 1.6. And of course, we can always take that and plug it in. Work through these real quick. So for this one, to get the x by itself, I would divide both sides by 15. And I get x equal to, if I simplify this fraction, I get 2/3. And then this one, I would divide both sides by negative 3.2. Negative 3.2. So if I divide both sides by negative 3.2, a positive 14 divided by a negative 3.2 gives me negative. So this would be, what is it? Z equal to negative 4.375. Now with your answers here, please don't forget to put the variable, like this one here, x equals. Please don't forget to write that. That is part of your answer. You need to state specifically x equals this, z equals this, x equals this, whatever the variable is. Okay, so here, multiply both sides by 4, because that would be the opposite. The inverse, that would be the inverse operation. The inverse operation here, I would multiply both sides by 4, and I get x equal to negative 36. The inverse operation here, I would multiply by both sides by 3. The inverse operation here, I would multiply both sides by negative 9. All right. This is just going to be part 1. I will have a second recording that you're going to need to watch, so I'm going to go ahead and stop it here.